Today we're going to finish Chapter 1 with Section 1-9, Functions and Graphs. So, first things we need to know, a function is just a relationship between an input and an output. So, keep in mind there's exactly one output for each input, and we'll go through this a little bit more in detail in just a bit. The independent variable is what we call the input variable. Okay, that's typically associated with the variable x. Now, it can really be any variable, but in general, we say it's x. The dependent is the output. That is typically associated with the y variable. And that's where the axis of the rectangular coordinate system comes from. So, at the origin, we have the coordinate 0, 0, for the two axes meet. The vertical line is called the y-axis. The horizontal is called the x-axis. And then when we put a coordinate pair together, we have x, comma, y. It's always in that order because we're in alphabetical order. It's what we call an ordered pair. Okay, so now, to help us remember what a function is, I like to think of a bow and arrow. Okay, so we have our inputs, we have our function, and we have our output. So the arrow is the input, and the bow is the function. So when we put the arrow in, when you shoot an arrow, it can only go to one spot. It cannot go to two spots. Got to keep that in mind. So a function will only allow an input to go to one exact spot. Okay? Just like an arrow. And now, keep in mind, two arrows can hit the same spot, but one arrow cannot hit two spots. All right? So that's how I like people to remember how a function works. Okay? So now, name the ordered pair at point C and explain what it represents. So we're going to find point C, and I'm going to mark it in red. So there's point C. So it is at 2, 75%. Okay? So that's the ordered pair it's at. Now, what's it represent? Well, it represents that after 2 days, because the x-axis is number of days, blood flow after a concussion is at 75%. I'm going to call it BF, blood flow, is at 75%. Okay, so that's what it's representing. Input, the input is 2 days, the output is blood flow after concussion. Okay, so now identify independent and dependent variables. Now keep in mind, independent variables are something that you want to look at as we control, what you can control. You get to choose what it is, and the dependent is what it's affected. Okay, so let's look at A. In general, the average price of gasoline slowly and steadily increases throughout the year. So if we think about it, which one can we control? Do we control the gas, or can we more think of the time of year? Okay, so like if we set a price, does that make the time of year? Or if we choose the time of year, does that mean we are looking at the price? Okay, so we got to keep that in mind. So what we're going to say, so we got to think, which one can we kind of control, or which one depends on the other? And it says, I'm going to use double underline here. So the year is the independent, and price would be the output of the dependent. So price depends on the time of year. Okay, art club members are drawing caricatures of students to raise money for their trip to New York City. The profit they make increases as the price of their drawing is. So again, which one do they more control, or which one depends on the other? And the profit depends on the price. So you can always kind of word it like that to see which one makes more sense, because we can't say the price depends on what we make as a profit. Like, no, it's, the profit depends on the price. All right, so now I already got it made out for us. The graph at the right represents the speed of a school bus traveling. Describes our, but let's look at this. So as we are going up, the bus is accelerating, and then as it goes horizontal, it's just driving down the road. Oh, now we're slowing down, and it stopped while we're probably picking up kids, and it continues throughout the day like that. Okay, so as the graph is going up, it is accelerating. As it stays slant, it's maintaining speed or stopped, and then slowing down. Okay, there we go. All right, identify the graph that represents the altitude of a space shuttle above Earth the moment it is launched until the moment it lands. So graph A says remember, it's when it's launched and then until it lands. So it's going to be launched and stay where it is for however long, and then come back to Earth till it lands. Well, that makes pretty good sense for graph A. Let's look at B. It's launched and then it just continues staying. So does it ever land? No. So graph B does not work. And then here, it's already in the air and then it lands. Well, where's the launch point? It never started on the ground. So graph C. So graph A would be our answer. Okay. For every 2 pairs of earrings you buy at the regular price of $29, you get a 3rd pair free. So I already got the table made for us. So make a table. So notice, 1 is $29, 2 is $58, then the next one is $58 also, because it says the 3rd one is free. Okay, so then the 4th one is $87, the 5th one is $116, and we can make an assumption that the 6th one would also be $116. So write the data as an ordered pair. Okay, so we have 129, 258, 358, 487, and then 116. So here are our ordered pairs. And then it says graph them. So I've got the graph already. Now we just have to graph them. So here we go. 1 is at 29. 2 is at 58. But 3 is also at 58. Whoop, I skipped a spot. Sorry about that. 3 is at 58. 4 is at 87, and 5 is at 116. So there is our graph of data showing how the price per pair of earring works. Okay, almost to the end. Domain is just another name for the set of inputs. It's not just one input, it's a set of inputs. And then the range is the set of outputs. Okay, and then a discrete function is a graph of points that are not connected. So like the graph we just did in the last slide. Those points were not connected because you can't buy the half of a pair of earrings. You have to buy the set. And then continuous graph has a line or a smooth curve, so all the points are connected. Okay. So Rasha rides her bike on average of 25 miles of 0.25 mile per minute up to 36 miles each week. The distance that she travels each week is a function of the number of minutes she rides. Identify a reasonable domain and range. Okay, so now this is a little bit trickier, but keep in mind, so let's look at the range first. The range is how far in this case, because the miles depends on the week, or on the pace, okay, or time. So we think the range, well, if she rides 0 minutes per day, well, that means she'd ride 0 miles. But if she rode the maximum she would do each week, well, it says up to 36, so she would have up to 36 miles. So the range is from 0 to 36. Okay, so I'm just going to put this 0 to 36. There we go. So now the domain's a little bit trickier. Okay, so obviously the start is pretty easy. The domain, we could start 0 miles total. Well, she could, now we got to figure out, if she's riding a total of 36 and it takes her 0.25 miles per minute, we just have to do some simple division. So we'll do a little side scratch work here. So we get 36 divided by 0.25, and that would give us 144 minutes. So she could ride 144 total minutes. Okay, so that's a reasonable domain. So next, draw a graph that shows relationship. Okay, so I have my domain and my range. So I'm just going to go by 25s on the y-axis here. So I have 25, 75, 125, and then let's see, I lost my spot, 175. Okay, and then I'm going to go by 5s on the y-axis, 5, 10, 15, 20. So my first spot, my first coordinate would be 0 minutes, 0 miles. And then at 144, I would have 36 miles. So 144 is approximately right here. Okay, so then 36 would be right about there. Okay, because we got 25, 30, 35. So there we go. So there you go. And she could write anything in between. So there is our continuous function. And part C just has, it's continuous because connected with smooth line. There we go.